Hello students, this is Mr. Boggs, and what we're about to embark upon is a series of videos on applications of derivatives. Now this content is largely from Term 4, Year 11 Math Methods in Queensland, but it does apply to a lot of the work you're doing in Year 12 Math Methods because the applications we'll be looking at in Year 11 probably just involve simple functions like quadratics and maybe cubics. But in year 12, you'll be applying the same rules and the same applications to, for example, exponential functions, log functions, and trig functions. So let's get started. Okay, if you're watching a maths video, at least one created by myself, you basically need to be sitting there with a bunch of tools by your side, or in this case, in your head. So to start with, you need to bring your eyeballs along to watch my math videos. You also need your brain, because when you're watching a math video, your brain should be engaged. What you should be doing is while you're watching, you should be thinking. You should be pausing the video at times and just reflecting on what you just learned. You might want to do what's called self-explaining, where you actually say to yourself, maybe just mentally, not physically saying it, what did I just see? What's the approach I have to take to solve a question like that? What's the first step? What's the second step? That helps you remember what you have to do when you do it in the future. So an active brain is essential. You will be asked to do some mathematics at times throughout these videos, so you need paper, pencil, eraser, or an erasable pen, one of the two. And you also will need at times a graphics calculator. So make sure you have all of those things before you proceed in watching these videos. So what are the applications of derivatives we're going to be looking at? Well, we're going to start by looking at the gradient of a function at any point. This is one you've probably done before. We'll also then use this to find the equation of a tangent line to a function at any given point. You might have done questions like that already back in year 11. You're going to look at displacement, velocity, and acceleration, because derivatives basically is the underlying mathematics behind all of that. You've learned how to sketch graphs, for example, quadratics and cubics, but it turns out once you know something about derivatives, you can also then find such things as maximum points, minimum points, and points of horizontal inflection. So we'll have a video on how to do that. And the main application of derivatives is a topic called optimization. So you're given a real-world situation and you're trying to maximize something. Like you might be trying to maximize the area, for example, under certain constraints. You might be trying to maximize the profit, trying to figure out how much you should sell something for. So you get a formula for that. The derivatives can help you figure out what the best sales price is per item to maximize profits and so on. So we'll look at two examples of optimization. And just to summarize at this stage, a function tells us the value of y for any given value of x. What the derivative tells us is the change in the value of that function, how fast y is changing for a given value of x. And since that's what the gradient of a function tells us as well, effectively when you're finding the derivative of a function, you're really finding the gradient of the function at any given point. Okay, we're going to stop there and then start to actually do the mathematics in the next video.